Hello bachcho. Today my topic is LCR series circuit and its resonance. For LCR series circuit, first we have an inductor of inductance L, capacitor of capacitance C and a resistor of resistance R connected in series to the source, alternate source of EMF, that E is equal to E naught sin omega t. I is the current flow through this combination. Then due to series combination, the voltage drop across each R, VL, VC and VR. Now here this VR, that is IR, VL, voltage across inductor, IXL and VC, IXC, where this XL, inductive reactance, and XC, capacitive reactance, and omega is the angular frequency of alternate source. We know when the alternate current flow through the pure resistor, voltage and current are in same phase. Pure inductor, voltage lead the current by pi by 2 phase angle, and in capacitor, voltage lag the current by phase angle pi by 2 when individually the alternate current flowing through it. Now we draw the Phasor diagram for the LCR circuit. Phasor diagram, this is O, x-axis, this is y-axis, and this is the y dash. Now we know VR, OA represent this VR and the current in same phase, and this OB represent VL, lead by phase angle pi by 2, and this OC, that is VC, lag by phase angle pi by 2. Here let me suppose this VL is more than VC. Then this VL minus VC represent by OD, and the resultant of this represent the EMF E, OE, and the phase angle is phi. So this is the Phasor diagram where we consider VL is more than VC. Now from this Phasor diagram, OE square is equal to OA square plus AE square, or we can say OE is IR square plus IXL IXC square root. Why we write here? Because this OA, this represent VR, and this AE represent VL minus VC, and we know that this VL, VC, VR, we use the values, and OE, this OE is a E, and here we have R square, XL, XC square. And how the current is written? E upon R square. This XL, XC may be written like this, omega L 1 by omega C square. Now here this component, this one, have the dimensions of resistance, total resistance of the combination, that is called impedance, represent by letter Z, and this is called impedance of the combination. What we got? We got the current is E by Z, where Z is called the impedance of the LCR series circuit, net resistance offered by the series circuit when the alternate current passes through it. Now for the phase angle relation, between the net voltage and the net current. From the phasor diagram, how we write the tan phi? Phasor diagram, tan phi is AE upon OA. What is the AE? Tan phi, AE is equal to VL, VC or VR. And what is here? This is XL, XC over R, or we can say omega L, omega C over R. Here we have the phase relation for LCR series circuit, where from the phasor diagram it clear that voltage lead the current by the phase angle phi, and that phase angle is given by tan phi equal to omega L minus 1 upon omega C by R. This is phase angle and this is called the impedance, and this is the phasor diagram. Now for the next part, that is the resonance. Resonance for the LCR circuit. To explain this resonance for LCR circuit, we've taken the impedance of the circuit, that is Z R square plus omega L omega C square, and the current E by Z. Now this Z depend upon the value of R, L, C and one more factor, that is called omega, angular frequency. When this omega is high, omega L high, 1 by omega C low, but when this omega is low, omega L low and 1 by omega C high. So we have some value, let's say omega naught, where these both terms are equal. When they are equal, then what about the impedance? Impedance become R square omega naught L omega naught C square equal, so they cancel R, and here this impedance become minimum, equal to only the resistance when this LCR circuit is at resonance, and when it become minimum, automatically the current will become maximum. So the LCR series circuit, when considered at the resonance, it gives the maximum current and the impedance is minimum, that is equal to the resistance. And how we get this resonant frequency? We get this resonant frequency from this relation. How we get? We get omega naught square LC. What is omega naught? 1 upon LC, or if we say frequency, because omega is angular frequency, then what is the frequency? That is 2 pi under root LC. This is the frequency. So this is resonance condition. What are the resonance condition? This frequency or this frequency, and at resonance Z is minimum, and what is the Z? That is called impedance of the circuit. And if we draw the graph to show the variation of maximum current with resonant frequency, this is the variation. This is current, this is frequency, and here this is the resonance frequency and this is the maximum current. So for LCR series circuit, Z is impedance, tan phi is the relation, phase relation, and when omega naught L is 1 by omega naught C, the current become maximum, impedance become minimum at the particular frequency, that is resonant frequency, and that is the frequency of the source. So when LCR circuit at resonance with the maximum